I'm sure. Hello, everybody. Welcome to our first AIS workshop of the semester, Introduction to Python. Can everyone hear me, by the way? Because I'll listen to the microphone and stuff. All right, so let's get started because it's 7 p.m. Who am I? My name is Aaron Chang. I'm a project director. I'm the new project director, as you can see, as I'm wearing a shirt over a shirt because it's not my new shirt. My email's right there. If you guys have any questions, qualms, want to talk to me, just email me there after the workshop or during the workshop if you want. I mean, up to you. One thing that I want to bring up is if you see this ask a question thing at the top. So instead of like me waiting for everyone to like ask a question or raise a hand, like that's kind of cringe and awkward, you can just enter this link and you can log into your Google account and you can send a question through that, and I'll get it up here and then I can present it or I can answer it and stuff like that. So it's just an easier way of getting questions to me. And it's easier so we don't have to like stop the whole thing. So the structure of this, we're gonna have about an hour of lecture and about 30 minutes of exercises because the best way to learn programming is actually to program. So try to follow within your notebook that I'll show it to you later, and try to work on all the examples that I show up here. So what's gonna happen? So first I'm gonna talk about why Python. We're gonna talk about the history of Python, the uses of Python, how to actually use Python, and then we're actually gonna start learning the syntax, how to use Python, and actually programming in Python. So one thing I want to do first is don't hesitate to ask questions. You can't learn if you don't ask questions, and it's just so easy. You just go to that link, type some questions in, and I can just answer them. You don't have to speak out loud or anything. So just ask questions, ask away. So one of the biggest reasons is why learn Python, or even programming in general. So I'm assuming a lot of you guys are CS majors, or business majors, or something like that, majoring at UTD. And Python is one of the greatest languages because it's so versatile in any major. So there's uses in the medical field, the business field, computer science, obviously. But the widespread usage of this language compared to other languages like Java or C++ or C, if you ever heard of those, is the reason why we're learning Python over those other languages. So what can we even use Python for? Python can be used in many ways. You can use it in servers for web pages. If you ever like use Google search, your search gets somewhere to be processed, and that can be written in Python. You can write machine learning models. If you ever heard of artificial intelligence, that's written using Python probably. And many other things such as scripts. If you ever heard of like hacking or CTFs, you can do things such as networking problems or de-assembling programs and stuff like that. So there's just multiple uses for Python. It's just prevalent everywhere. So that's why it's one of the greatest languages to learn. So one thing I want to bring up first is failing. Coding is all about trial and error. You're not always going to get it right the first time. I always code, and I always get errors whenever I do it. So don't be afraid of failing. Don't be afraid of trying new things, fiddling in the notebook, changing things, getting error code. Error messages shouldn't be scary. They're meant to teach you about what is going wrong with your code. It's not to yell at you for doing something wrong. So always read them because they're meant to be read to debug your code. Just don't be afraid of them. So the history of Python. It was started by Guido van Rossum as a hobby, and obviously it's more than a hobby now. In fact, it's the second most used language in 2020, just being out by JavaScript, front-end developers, I guess. But it's extremely widespread. You probably already heard of it if you never even like used it before. You probably already heard of it somewhere. Just because it's, like I said, very versatile and very prevalent to use everywhere. So uses of Python today. So Python is mainly used for, and you've probably heard it used in scientific computing and data analysis. This includes things such as artificial intelligence, machine learning, deep learning, reinforcement learning, all these learnings, all these buzzwords. It's probably used in that. But it's also very important in software development and financial markets and cybersecurity. All these different fields that most of you are probably going to go into probably uses Python. And then it's also used in many packages, which are used like DLC. It's like an add-on to the language. These basically add extra features, like NumPy adds more mathematical calculating abilities to it. TensorFlow adds machine learning capabilities to Python. Matplotlib adds graphing capabilities, and Django adds back-end server-side capabilities. So all these packages are used widely throughout the world, throughout software engineering. So there's 3 main ways to use Python, and I'm going to talk about 2 here. So one of them is called Ipython, which is short for interactive Python, and this is where it can be run interactively. And it's usually run in your terminal, and we're not going to go over this today because we would have to install Python, which is a long process. And this isn't really used by most people. It's only used mainly for researchers because you can only type one line of Python at a time. So it's used for like manipulating databases or spreadsheets and stuff of that sort, not really writing whole programs. So the next step is Python scripts. This is mostly used by software engineers in general, people who are trying to write large code bases, lots of lines of code. And you can't really write that in Ipython because you want to write 10,000 lines of code in one line by line. So they're written in text files with a .py extension. And this is used if you want to run more than a few lines of code using the Python interpreter, as Python is as an interpreted language. So this is what we're going to be using today. It's called a notebook. We're going to be using specifically Google Collab. The reason why is it's an easy to use environment. Everything's already installed for you. You don't have to go through having to go through the rows and be like, oh, I can't do this, I can't do this, and help figure you guys your problems out. It's already all installed and ready to use. It's web-based, so you can just do it in your web browser. You don't have to download anything. Lets you combine text and code, as you can see when you open the notebook I'll give you. You can see that I wrote some stuff down, and you can read the text while doing the code. And one of the biggest things is that you can use computing resources more powerful than your own. Google Collab allows you to access their hard drives, their RAM, and their graphics card. So Google servers are probably more powerful than your own laptop. So it's just an easier way of training machine learning models if you ever want to do that, or just accessing more power that you don't have on your own laptop. So opening the notebook, if everyone goes to this link right here, intro.nasuno.me, it'll bring you to a GitHub repository. And if you click the little button that says Open Collab, it'll open a new Collab notebook, and you'll see a bunch of stuff pop up. Try not to click anything, and I'll help you get through about what's going on over there in a couple seconds. So I'm just going to wait a tiny bit for everyone to go to that link and open the GitHub notebook. Is it good? Okay. So it's Open Collab. You have to log in using your Google account. It's Google Collab. A couple more seconds, and then I'll move on. 5, 4, 3, 2, 1. Don't forget, you can ask questions up there if you have any questions, like you can't open it or something. So one of the biggest things about running a notebook is that you'll see a bunch of these squares, right? You see a bunch of these squares. If you mouse over the squares, on the left side, you'll see a little play button. If you click that play button, you can run the code. So if you see where it says, welcome to the first AIS workshop of the semester, if you mouse over it, you can see a little play button on the left. Click it, and you'll see on the output, it'll print out welcome to the first AIS workshop of the semester. Also, if you want access to the slides, there's a link to the slides in the top. Click the hyperlink. So now that we know how to run code, let's actually write code. So we're going to be going through the agenda. So one of the first things we're going to be talking about is commenting, and then we're going to go printing, arithmetic operators, strings, types, Boolean logic, lists, tuples, dictionaries, sets, loops, functions. Don't worry if you don't know what any of this means. We're going to learn it as we go on. This is just so that I know what's going on and helps pace me through things. So we're going to be learning all of this today. So let's get started. So the first thing is called commenting. Commenting is very useful in Python and any programming language you ever learn. Basically, it allows you to write text without having to being run as code whenever you press the play button. So if you see under commenting, you can see thanks for coming in comments. If you click play on that, nothing comes out because since you put it after a hashtag, it does not get read by the interpreter. So that's one of the main things of commenting. You can write your own comments if you want. You just put a hashtag space and it won't get run. And you're going to see a lot of this as just documentation purposes throughout the whole entire notebook. So printing. Can I not present this? Okay, well, someone asked what the link was. It's intro.nasuno.me, and they can access all of this stuff. So printing, whenever writing scripts, your output isn't printed on the terminal, so you have to use this function called print, and we'll talk about what functions are later and what it means. But basically, if you type print parentheses, close parentheses, anything you put between those two parentheses inside quotation marks gets printed out as text. Obviously, right now, it doesn't seem that cool, and you can't really do that much with it. But if you see where it says whoosh and print whoosh, if you click both of them, they both output whoosh. So the reason why it prints, even there's no print in the first one without the print with the whoosh, is because in notebooks, we're able to print text if we don't type print. This is specifically for notebooks. If you just click play with the string of text or variables, which we'll talk about later, it just prints it out. So that's just a really easy to use thing for notebooks, but whenever in doubt, always use print because this is able to be used in notebooks and normal Python scripts. So one of the core things of Python is math. And here we're going to look at all the arithmetic operations. As you can see this on your notebook as well, but I'm just going to bring it up here. We can see all the different symbols that we use to do math within Python. So you can see addition is plus, subtraction is minus, and so on and so forth. Interesting one is mod. I don't know if you guys ever heard of mod before, or it's called modular inverse. What it does is it's the same thing as division, but instead of giving what like 5 divided by 2, instead of giving you 2.5, it gives you 1, because it gives you the remainder of what is left after dividing. So 5 divided by 2 is 4 with a remainder of 1. It returns the 1 instead of the 4. I mean, yeah, 2. I mean, yeah. So next one is multiplication, which is an asterisk. That's multiplication. Floor division is division, but it rounds down. So let's see, 5 divided by 2 would be 2. And then power of, so that's the 2 asterisks, so it'd be 7 times 2. That'd be 7 to the second power, which is 49. And if you look at this table, actually this is the table precedence, which means what gets evaluated first from the bottom up. We can see that exponents get evaluated first, then multiplication, division, and then mod, subtraction, and then addition. Basically follows the same rules of PEMDAS, if you remember what that was from like middle school. So here we have an example right here, and you can see in your notebook too. We're going to evaluate the way it gets friended out. So you can see that whenever you run it, you get a 64. The reason why this is because the first thing that gets evaluated is 16 squared, which is 256. And then you divide it by 4, which gives you 64. And that's how precedence works. Someone says they missed a few steps, can't find the coding page. I'm on a menu. So if you're on a menu, it should say in the top left GitHub, where it should have like a lot of things. If there's a little badge that says open in Collab, if you click the little badge, it'll open what we're looking at right now. So Python has a calculator. In order to do math, we just type it into the cell, as you can see. This is done in your notebook. If you look under the 16 to the squared, divided by 4, you can see 1,816 times 1.609. The 1,816 is actually the distance in miles from the MIT of the South to MIT, and then it's multiplied by 1.609 to turn it into kilometers. So this is great and all. You can do calculators. You can do calculation. You can do 2 times 2, 2 divided by 2, 4 times 2 plus 2, 5 plus 6 divided by 2, so whatever you want. But what does this mean? Why do we need to learn this, and why is this important? So one thing that makes it important is that we can use things called variables. Variables are storage mechanisms. They're like little boxes that let us to put values in and then be able to reuse it later, so that we can store things and not just lose them to the void of the computer. So if you look down in variables, we can see that we assign 1,816 in miles. So basically we're putting the value 1,816 in the box that's called miles, so that we can bring it anywhere that we want and use it for whatever. We do the same thing with ratio. And then if you look at kilometers, we're using miles times ratio instead of the numbers. So basically what this does is it allows us to reuse numbers that we already defined before, don't have to redefine them again, and we can use them again. So basically this does what we did earlier, but everything's stored so that we can reuse it for further use, not just lost to the void. So here, if you guys look on the next part, we have miles equals 28. I want you guys to fill in the blanks about what would go in there so that we can convert miles, which is 20 miles, to its equivalent in kilometers. So I'll give you guys a couple of seconds. Fill in the blanks. There's some underlines that you can delete. But you don't have to define types in Python. They're automatically defined. You can also change them. You can reassign an integer to a string. You can reassign a string to an integer or a float. If you don't know what that means, we're going to talk about it further more. So I'm going to give everyone a couple more seconds to do this, and then I'll review the magical answer. So it's miles times ratio. I mean, it's pretty easy, but the concept is that you can put stuff in a box and then reuse it later. That's really important to know because that's one of the core basics of programming. So strings, like I talked earlier, strings. What are strings? Strings are very powerful and flexible in Python. They can be added, they can be multiplied. But what are they? They are just text. It's just words. And if we look at here, we can store different variables, and we have to use quotation marks to define them. So we can put artificial, and we can put intelligence, and we store them in the variables x and y. And then as you can see, we can do x plus space plus y, and then print it out, which gives us artificial intelligence. We can do addition with strings, and only strings. You can't do addition with strings and integers or floats or any numbers. But you can do addition between strings, and this is called concatenation, if you've ever heard of that. It's a programmer's term, but that's what it's called concatenating strings. We can also do multiplication, if you see over here, x plus space plus y times 3. If you're gonna try that on your own in the little box that you guys have that has the example above, you can multiply by 3, 4, 50, 6,000. It basically just reiterates that word and keeps concatenating that many times 3. So we also have some methods that we can do with strings. And what methods are they're basically just like commands that we can put on strings to make them do something or change them or mutate them in some way. So if you look in your notebook, we can see that there's x equals Dallas, which is all lowercase, and then we can see x equals x dot upper. What that does is it turns it to all uppercase. And then we also have y equals University of Texas at, and then we have y equals y dot lower. That turns it to all lowercase. It's pretty self-explanatory. I mean, Python is supposed to be meant to be easy to read and easy to comprehend. And if we see at the end, we print out y plus x, and that adds the words together, also called concatenating. So one of the main things I want you guys to take away from that is that we can do things called methods to variables. So we can do x dot something something to manipulate it in some way. Just a core concept that will be showing up a lot through the rest of this presentation. So what's a way that we can make that shorter? One of the things that you can do is printing instead of storing in a variable, like we stored y equals y dot lower and x equals x dot lower. You can actually just print it out like this. You can just print y dot lower plus x dot upper. The main fallacy with this is that sadly y dot lower and x dot upper doesn't get saved, so you have to store in a variable. But otherwise, you can just print it out like this just for ease of use. And then if you want to see more string methods, more dot something something that you can do, you can run the little box that says dir string. That basically just shows you a bunch of methods that you can use on strings. You can take a look at them at your own time. But there's a lot of things that you can do, and they're all built in Python just for you to use. So types. So what are types? Types are what a variable is. It's what's stored within it. It's what the contents are. So all variables have a type. So we can see all the types here. As we already talked about, we have an integer and string. That just means a number without a decimal point and like a line of words. We also have float, which means a decimal number. So 124.56, or any decimal number, including 1.0, 1.000. That is included as a float. If it has a decimal point, that's a float. We also have Boolean. Boolean, I don't know if you guys heard about it before, but this is a really used word in computer science, and it basically just means true or false. If a variable is Boolean, it can only have two values, true or false. And then we also have none type, which means that it's just nothing. It just doesn't exist. And this is used when you want to declare a variable, but you don't want to put anything in it. So if we look here, we can see all the different things. Float was changed because you can't name things floats because that's a type, and I goofed. But there's an integer, and then on your thing, float is changed to decimal. There's a string, there's a Boolean, and there's a none. So if we print it out, we can see we print the string form of integer is of string form type integer, and which we see here, 21 is of class integer, 3.14 is of class float, so on and so forth. We can see all the different types and how they're represented within variables. So what does this print? Anyone want to type in the questions thing or just say it out loud? What is dir string? So dir string basically stands for directory, and it prints out a directory of all the methods that you can use on a string. You can also do dir int, you can do dir floats, you can do dir none, and stuff like that. Well, not dir none, that just means nothing. But so what would this output? actually outputs an error. If you run it yourself, it throws out an error, and it's like, whoa, what's going on? What's going on? So let's take a look at this. Reading errors is a very important skill of learning Python and programming in general. So let's read this. If we see there's an arrow to where we did something wrong, and it's saying we did something wrong on line 3, which is x plus y. And it says that we have a type error, unsupported operand types for plus, int, and string. So what does that even mean? So let's start off from the beginning. Type error. So that means it has to be with an error with the types. So unsupported operand types for plus. So operands are the things that you put together using operators. So it's basically saying x, which is an integer, y, which is a string, are unsupported types for plus. And this is because you can't add integers and strings together. You have to have the same type when adding anything. It has to be string, string, or integer. You cannot mix and match. So the kinds of tools you should use at home on your own times out of AIS workshops, you can use Google Collab. On the GitHub that I posted, the little menu thing that you guys click the badge, I'm going to put more resources on there afterwards, like a whole guide to setting up Python, how to use it at home, IDEs, notepads, everything, and just be able to just make sure to read that afterwards. I forgot to push it because I have to get here, but it will be up there when I get home. So what is a string? A string is basically just a bunch of text. It's not numerical, it's based on characters, it's part of it's just text. Like you can represent numbers as text. So as you can see there, 20 is represented in text. So it doesn't have any numerical value, it has character values. So this is very important. We cannot do arithmetic operations of variables with different types. So always try to make sure that you're aware of your variable types, especially since you cannot declare explicitly type your variables as you do on like other languages such as Java or C++, where you have to do int, string, and you can't mix and match. In Python, it's all up to the end user. So you have to be very careful in tracking what you put in there. But you can always find the type of variable using type parentheses parentheses. So if you try type x, it will output class int. So what happens if we do want to add a integer and a string? We have to convert the variable, right? So this is how you convert variables to different types. It's called casting. Casting is the operation of converting a variable to different types. And basically, you put the type you want to convert it to, and then put parentheses around it as we would do in print. And this is called a function, and we're basically passing the string to the int function, which turns it into an integer so that we can add it, and it prints out a numerical value, 30. There also exist the forms int, parentheses, parentheses, float, and strings, so you can turn things into integers, floats, and strings. So this is very important to know, as you can't do mingling between types whenever you're doing mathematical operations. Can you add integers and floats? So yes, you can. You can actually add integers and floats, and it gets converted to a float. Strings always have to be in quotation marks. Strings do always have to be in quotation marks. It can be double quotes or single quotes. They're both the same. Yes, for our use cases, it's the same. It's easier for me to type single quotes, so I use single quotes a lot. But if you really love double quotes, you can use double quotes. So, pop quiz. What is the result of x equals 10, y equals 20, x plus y? Type it in the link above. I'll wait a couple seconds. So, human intuition would just make us 30, but that's not the case. It's actually 1020 because it's a string. It's just 1020 because it's adding the word 10 and adding the word 20. It's not adding the numerical values. If you did want to add the numerical values, you would have to put int parentheses x close parentheses plus int parentheses y close parentheses to add the numerical values. So strings and numbers. Try to keep numbers as numbers. Try to keep strings as strings. As you can see here, x equals 6. And then x equals x times 446, 4 divided by 63. That's a lot of math. I'm just going to tell you. It equivalates to 42. As you can see, the answer to life, the universe, and everything is plus string x. You see how we convert it to string whenever we're printing it. and not when we're storing it into a variable. This is because we want to keep numbers as numbers, like we said, and strings as strings. So we only convert it when we really, really need to, or else it detracts from us having it as a number in the first place. A lot of people put 1020, that's correct. So what's wrong with this code? Well, let's take a look at it. So we have string 1, string 2, string 3. String 1 says I really like the number. String 2 says 9. String 3 says it's really nice. And then we try figuring it out, but we have another type error. So it's back to the types. So type error, you can only concatenate strings, not integers, to strings. So if you remember what concatenating is adding strings together. So we can only concatenate strings to strings, so that means we can only add strings to strings, not integers. And as you can see, string 2 is actually the number 9, not the word 9, or the string form of 9. So in order for this to work, we would have to type in line 5, we have to cast it to a string, or we can put quotation marks around the number, line 2, and turn it into string whenever it's stored into the variable. Are we allowed to have two variables of the same name with different values? You cannot have variables with the same name and different values. It all has to be unique, because if you think about it, if the two variables had the same name and you called it, how would you know which one you're calling? But you can really reassign variables, as you can do x equals 2, and then you can x equals cat, and then x equals 3.14. You can't do that in other languages. In other languages, you have to specifically determine that it's going to be an integer from the start, and it will only be an integer. In Python, it's different. It's very dynamic, and it allows you to reassign and reassign and reassign over and over and over again to your heart's desire. Okay, so now that's all we have with the types, and those are all the basic data types that you're going to be working with, and all that you'll see: strings, floats, and integers. So now we're on to comparison operators. This is part of Boolean logic, and this is basically where we bring in the Boolean values that we talked about, true and false. So what comparison operators do is they return Boolean values, and these are used in conditional statements, also known as if-else statements, which we'll be talking about later. So if you see in the little table on your little notebook, you can see all these things. So x equals y is true if x equals y, x not equals y, or exclamation point equals, that means not equals. That's true if x doesn't equal y. X is less than y is true if x is less than y, x is more than y, and so on and so forth. It's pretty self-explanatory. One of the major important things to understand is that you have to notice the double equal sign on x equals y. If you only have one single x equal mark, that means that you're assigning the number 5 to x, which will always be true. You may have to make sure that x has to be equal to 5, which in this case outputs true because we already assigned it to the value 5 earlier. And then if we test it on the bottom, we can see that x is more than 7. That's false, because obviously 5 is not bigger than 7. So if you guys see the little box with a bunch of, there's the first line that says 43 is not equal to 42, that equates to true that I wrote. I want you guys to fill out the rest of the green hashtags. And I'm going to give you guys a couple of seconds to do that, 1 minute. Just fill it out, put whether it's true or false, and then I'll review the answers up here, and then we can talk about it if we have to. Also, I saw some people join us. If you need the link to join, it is right here. This is the link to find everything. Go to this link. You can click the little badge that says Open in Collab, and you can open the notebook that we're working on. Oopsies. Okay. Anyway, so I'm going to assume that you guys have enough time. So let's talk about it. So these are the answers. We're going to go through them. It's okay if you're wrong on some of them. I mean, this is pretty hard to, it was hard for me to understand them because I never thought about true or false like that. Okay, let's go through it. So 20 equals 21. Obviously, that's false. 21 is not equal to 20. That's true. 10 is less than 18, that's true. 10.2 is more than 10.1 is true by 0.1. 19 is less than or equal to 20, that's true. And 22 is more than or equal to 28, that is false. So this is one of the basic building blocks of programming, so try to make sure that you understand it, at least kind of. So let's talk about logical operators now. These help extend conditional logic. So we have three types. We have the or, the and the not. If you see, so whenever it's x or y, that's only true if at least one of them is true. X and y is only true if both are true, and not x is true only if x is false. Basically, just flip-flops that value. So if you put not true, that is false, and if you put not false, that is true. So let's do some more examples. So as you can see, there's a little, we're gonna go through these. There's a little one that already filled out. So false or true, this equivalates to true because using or, only one of them has to equivalate to true. So this equivalates as true. False and true, this equivalates to false because whenever you're using and, they have to be both true to be true. When they're both true, then it outputs to true. And then not false and true. This outputs to true because not false, you flip-flop it, so it becomes true. So the end statement is true and true, which equivalates to true. And then we also have not, false, or true. You can just put true because it's or, so only one of them has to be true, so the whole left side is totally void. I totally forgot what that equivalates to, but if someone wants to figure out, you can go do that. So that equivalates to true because in or, only one of them has to be true, so you can ignore the whole entire left side. So there's another section under that, and I just want you guys to take a look at it and just fill it out. As you can see, we introduced numbers, so you have to equate. You have to find out what that equals first, and then you have to figure out what the other equals first, and then you have to put it all together. All right. So let's take a look. This is what they equivalent to. So let's go through it again. True and true. That's true, obviously. False. False and not true. That equates to false and false because not true flips it. 19 is more than or equal to 21 and 21 is less than 10. So let's break this down. Is 19 more than or equal to 21? No. And 21 is less than 10? No. So it's false and false, which comes out to false. 8 equals 7, false, or 21 is less than 18. That's false. So both are false, so it equates to false. Not true and not false. So not true, so it's not true, so it's false. But then it's not false, so it's true. So two nots cancel out each other. So it's true and not false, so it's two truths, so it's true and true. Don't forget, two nots cancel each other out, so it's a big thing. So here we have another example. X equals 14. I want you to check if x is within the range 10 to 20. So if you see the two underlines, I want you to replace that with the correct comparison operator, i.e. less than, greater than, less than or equal to, greater than, equal to, not equal to, equal. So I'll give you a couple seconds. And it should be more than or equal to and less than or equal to. The reason why we put the equal to is because it's from 10 to 20 inclusive. And then it outputs is true because obviously 14 is in between 10 and 20. So what is the point of learning all these ands or less than, whatever? It's for using in if-else statements. So these are the fundamental building blocks of programming. You've probably seen it in program pictures, if-else, blah, 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 or those cringe like programming t-shirts like if something, eat, sleep, whatever. So what are these? We have the conditional statement, we have the the command that's executed if that conditional statement becomes true, or it does another answer if it's false. So let's take a look at this. So here, if we look at the first block, we have x is defined as true. So let's go through it. If x, so that means if x is true, it executes if, else it prints executing else. So this is very based in the human language. So if x is true, it prints executing if, and x is true, so we execute if, and then we skip the else statement, and then we print this always prints because that's outside of the if else blocks, which are marked by indentation, which we'll talk about later on. But if x was false, let's presume x was false, we can do if x is true. It's not. So we go through the else block and we print executing else. It's really rooted in human language, like I said, and just whenever in doubt, just read it. And the conditional next to the if keyword has to evaluate to true in order to go to that little indented block of code for the if statement. Can you use braces for if else? So that's another quirk of Python, is that there are no braces, there are no semicolons. Everything is done through indentation, so white space is very important, and you have to keep track of your white space. So, like I said, indentation matters. Code is grouped by its indentation. It's not grouped by brackets, like it would be normally done in C++, Java, JavaScript, or any language. Indentation is the number of white space or tab characters you put before the code, and if using tab, I convert my tab to spaces because I like spaces, but if you put code in the wrong block, you will get unexpected behavior because it will run with another portion of the code that you didn't really need for it to run. So always keep track about the number of tabs that you're putting in. So let's look at this huge block of code. This is a total of information overload, but I'm just going to break it into blocks first. So this is really confusing, but if you can see that all the squares that are grouped together are by the same indentation, but this is kind of confusing to understand, but one thing that I would break it down by is by using a bullet analogy where it's like a bulleted list. And we can convert that to this. And you can see this in your notebook too. All the bullets that are matched together means they're on the same white space and indentation, and that means they also run together. So as you can see with the white dots, we can see if we go through it, if x is modulo 2 equals 0, that means whenever you divide x by 2 and there's no remainder, i.e. it's even number, you print string x is even, and then you do the next bullet, if x divisible by modulo 5 equals 0, that means it's divisible by 5. It prints that, else it goes to the next bullet point. So as you can see, it runs through all the code based on the same bullet point that it's in. It's kind of like brackets, if you've ever done that, and how the brackets are like breaking everything apart. In this case, it's indentation. So it's kind of easier to look at, but it's also more confusing to understand. So I recommend comparing this and the block of code that you have in your notebook, and just make sure that you understand how they're grouped together and how they run. So what if we wanted more than if and else statement? What if we wanted else if and continue our if statements to more stuff? So that's what we have. Else if blocks. So if we have if a condition and that's false, it goes to the else if that we can define with another condition. If that's false, we can put another else if with another condition, or we can just put an else. You always, whenever you do conditionals, there's always an if else, because the reason why is because if it doesn't pass the first conditional, it always has to go to the else statement. So that means the thing that you're trying to test for the conditionality is always going to be put into a category either true or false, or in this case, it's ternary, which means there's 3 things that I can go into. So we have a Bitcoin bot that we can use, and if you click play on it, it's going to ask for input. And then you can type a number, click enter. It's going to ask you for another number. You can click on it, type another number, click enter. And then it's going to run through this code, and then it will spit out some words that either don't sell, you should sell, or the price has really changed since you bought. And it's really confusing to look at this at first, but one thing about coding that I learned is that you always have to break it onto chunks, because coding is not a black magic. Everything you type is what gets done and ran through, so everything is explainable if you just look through the code bit by bit. So if we see we purchase price equals float input, so we convert the input to a float, and the current price equals float input, which means we convert the input to a float again. We can see that if the current price is less than the purchase price times 0.9, so what does that mean? That means if the current price is less than 90% of the price that you purchase at, it's going to tell you you don't sell. Because obviously you don't want to sell if your current price is lower than what you bought it at, you'd be losing money. If that's false, then it goes into the else if. If the current price is more than the purchase price of times 1.2. So that means if the current price is more than 120% of the original value that you bought it at, it's going to tell you you should sell because you want to make money. Else, if it's not, if the current price is not less than 0.9 and it's not more than 1.2 times, then it's just going to tell you the price hasn't really changed. Because that's true. Because if you reach the else statement, that means the current price wasn't less than 90%. It wasn't more than 120%. So that means it's between 90% and 120%, which is about 100%. So that's basically how you trace conditionals, and I would always recommend looking through the code whenever you're confused about something. So another pop quiz. What would happen if both conditions were true? So as you can see, we flipped the current price more than the purchase price. So what happens if it was more than 120% of the purchase price, right? That means it'd be more than 90% and be more than 120%. Because the current price more than purchase price times 90% is first, that would be evaluated first. So we would actually go print off don't sell now because that's the first one that we ran into. If we change the order and it was if current price is more than purchase price times 90 under 1.2 and we flipped them, it would output this. So order is very important in the ways that you put your conditional because code goes through structurally. It always goes from top to bottom. So it always checks this one, and then this one. So always make sure that whenever you're writing conditionals, always think of the edge cases because there's a lot of edge cases that you can think of. Like if you're testing GPA, if you test if it's more than 40%, but then you have another one that tests if it's more than 50%, it's going to go through the first one. So you have to go from top to bottom instead of bottom to up. So that's the end of basics. Oh, we went through a lot. Hopefully you guys learned a lot. And we're going to take a short 2-minute break because that's a lot of information to process. If you have any questions, type in the questions. I'll look at them. If you're a member of AIS and you signed up to it and you got accepted, use the QR code and the link that you can track your attendance. I think it asks for your net ID and you can put in your number, put that number in and it will track your attendance. Don't forget you have to attend 1 event per month. I'm going to take a short 2-minute break. Ask any questions if you want. Just process everything that we learned. Take a good look over everything. I'm just going to jerk it really good. Okay. But I have to push it. Then you read me. So I have to wait until I go home. That's on me. Push it right now. It's on my home desktop. So there's a lot of questions on membership. We actually opened membership applications a long time ago, and they already closed. So sadly, you can't become an AIS member anymore. But you don't have to sign in if you are not admitted through that process that we had like a week ago or 2 weeks ago. What? Oh, it's like sign in? Oh, yeah. Yeah, one thing that I guess I have to explain is that anyone can come to our workshops. They're open to everyone. We just have this specifically for members that are like signed up members of AIS because we have like specific events, like requirements that they have to go to and show up for attendance requirements. But all of our workshops are open to everyone, so don't be afraid to come in. We have another workshop this Friday about deep learning if you guys are interested about that. But let's continue. So we got over with all the basics, all the types, all the Booleans, all this stuff. So what do we do now? What is more advanced than that? So now we're going to be talking about data structures. What are data structures? They're structures to format data. So one of the first things we're going to talk about lists. Lists is one of the most useful concepts that you're going to use in Python. It's basically just something that groups a bunch of values together inside a little container. So if you look at your notebook, we can see that the format of it is list equals square bracket, a value, comma, a value, comma, a value, comma, so on and so forth, and then close square bracket. If we can see on the things, we can see that we initialize a list called fruits with apples, tomatoes, persimmons, and oranges. So if we print out the type and then we print out what's in it, you can see that it's a class of list, so that means it's a list, and it has the fruits, apple, tomato, persimmon, and orange. It basically just stores all those values so that we can access it later. A persimmon. So a lot of people don't know what persimmons are. Persimmons are personally my most favorite fruit. You can look it up. I don't know how to explain it. I guess it's like a mix between cantaloupe and honeydew. That's not a good explanation either. You have to taste it to understand, bro. I just don't. Sad. But it's really good, I swear. So how do we access the list? Once we already stored all this stuff, how do we get it out of it? Otherwise, it'd just be useless. We use something called indexing. Indexing is, what it means is that you access the items within a data structure. And to access the items within the data structure, you put the name of the list, and you put bracket, the item you want to access, and then close bracket. So this one, we're trying to access the index of 1 from the list fruits. So what do you think this is output? Obviously, for normal human intuition, we would say apple, right? Because it's the first one. Well, sadly, coding isn't that easy, and that's not the right answer. It would be tomato. Why is this? It's because Python is a language that uses zero indexing, like most other programming languages, with the exception of Lua and probably some other things that I don't know about. So this is actually how stuff is indexed. Every list, tuple, and dictionary, all we're going to, not dictionaries, that we're going to talk about, they all are indexed starting at 0. So don't forget this. So even though there are 4 items, there's actually the number of the max index is 3. So don't forget that, because if you do 4, it will throw an error. So will fruit 3 return? So as we learned, it wouldn't return persimmon because it starts at 0. So we'd have to go 0, 1, 2, 3, and we stop at orange. So fruits 3 returns orange. What does fruit 4 return? Try testing this out in your notebook. I already kind of spoiled it, but it would throw an index error. Unlike the type error before, this is error with the index. What this means is that the list index is out of range. So that means we're trying to access something in our list that doesn't exist because there is no 4th index. There's only a 3rd one because it's 0 index. Don't forget about the 0 index. Can you put different variables on, can you put variables of different types into the list? Unlike most other languages like Java and C++, yes, you can in Python because it's dynamically typed. You can put whatever variables you want, as you can see later. You can put integers, booleans, lists inside of lists. You can put strings and stuff of all that sort inside of lists and mix and match with them. So one of the most important things about data structures is you have to make sure that you're aware of the sizes of your data structures. This can be used. This can be done by using the function length, and if you do length of fruits, it outputs 4 because that's 4. But don't forget the index of the last element is 3. So what if you don't like tomatoes? I don't like tomatoes. They're kind of gross. They're like watery. They taste like weird water. So in order to replace things, you take the index of the thing you want to replace using bracket notation, and then you equal a thing that you want to assign it to. So we're assigning the first index of fruits to peach. So we're replacing tomatoes with peach. And then we can print out fruits again. As you can see, tomatoes replaced with peach. And then there's also methods that we can use on fruits, such as methods with strings, such as upper and lower. We can do append and remove. What append does is it appends whatever you put in there at the end of the list. So we're putting line at the end of the list. You can do remove. Remove is where you put in the object that you want to remove, not the index, and it removes it. So we're removing the word orange. So this is a function that's very important in Python. It's called range. And it basically, we can generate a list with integers, but range is also used in for loops, which we'll talk about later. And if we can see here, nums is a list of range 10. So what does that mean? Range, it goes from 0 to the max bound, which is given there, not including that max bound. So as you can see, it generates a list from 0, 1, 2, 3, 4, 5, 6, all the way up to 9, not including 10. That's very important to understand, is that Python and most other programming languages strings start at 0, and whatever you put in there isn't really included all the time. So as you can see, we gave one number there, but if we see here, we gave 3 numbers here. So what does that mean? The first number that you give is what it starts at. So we're starting at 0. The next thing is 100. So we're going up to 100, but not including 100. And then the third one is the step size. We're going up by 5s. So as you can see, it goes from 0, 5, 10, 15, all the way up to 95, not 100. So here are some more helpful functions they can use for a list. There's length that we talked about. There's max, which returns the maximum element, which would be 95. And then there's min, which returns the minimum element, which would be 0, because we made a list of numbers from 0 to 95 with a step size of 5. So list 2, electric boolean. Mix, as we talked about before, you can have a list with any type. So you can see we have an integer, a string, Boolean value, another type, and then we have a list within it. So you can mix and match types. I don't know why you'd want to, but it's definitely a thing that you can do. So your turn. Try making a list that has 4 elements, with the 4 elements being your favorite foods. It's a little blank square that has a comment that says enter your list here. So try making that. So we're kind of running low on time, so I have to speed forward. So this is basically what it would be. My favorite foods are boba, which I guess technically isn't a food, but it is to me. Korean barbecue, ramen, and pho. Those are the foods that I enjoy. But you can put whatever you want. It just has to be in this format. We have a bunch of 4 strings, and then they're separated by commas. This is how you create a list. So now we're going to extend onto more data structures. This is called a tuple. A tuple is a list that can be changed, and unlike its name, whenever I started learning tuples, I always thought it was just a pair of 2 things. That's not true. Tuples can be whatever size you want. And it's denoted by a parenthesis instead of a square bracket. And so if we see, we can print type fruits, and we can print fruits. You can see that it's a class of tuple, and it prints out tuple. Main thing important to know about tuples is that you can't change them. They're unchangeable. Whenever you try to change it using bracket notation, not using parentheses, use square brackets, try and change the first element to cherry, it's going to throw a type error because the tuple object does not support item assignment. That's because tuples can't be changed once you initialize them to a variable. Now we're speed running past this, but dictionaries. This is a very important concept, and it's kind of got to be hard to understand at first, but these are similar to actual dictionaries, and it's 2 lists that are zipped up to each other. And these, this is a data structure that uses keys to access values. The keys are on the left and the values are on the right. And each value is mapped to a unique key. So instead of accessing it like a list with the bracket notation with a number of the index, you have to access it using the key that you're going to use. So in order to create it, here is the definition for a dictionary. As you can see, there's brackets, curly brackets instead of parentheses or square brackets. And then we have the key colon, the value that you want to associate with that key. You can search by keys, but you can't search by values. So if you want to find the value, you have to remember the corresponding key. So dictionary properties. Values are mapped to key, like we talked about, and they're accessed through that key. They can't be accessed through the values. It only goes one way. Keys are unique and immutable, which we'll talk about in a second what immutable means. And values cannot exist without a key. One of the core concepts you have to understand is that everything is accessed through the key, and not through the value, and that every value has to be associated with a key, and every key has to be associated with a value. So let's define the one from the first image. I already defined it. This is what it would look like. So we would have Monday, comma, DON, Tuesday, comma, dimmer, and so on and so forth. These are the English names for the days corresponding with the Irish Gaelic versions of it. And so we can print out the type, and it's across the dictionary, and we can print it out, and you can see that it's basically printed out in the same format that we defined it. Are there any recipes that use persimmons? There's dried persimmons. That's the thing. I don't think I recall anything else. Why do I hate tomatoes? They taste like weird water. Only cooked tomatoes taste good. And what exactly is a tuple? So a tuple is just a list that can be changed. That's it. It's just a list that can be changed. One of the main reasons a question that you would have is, why do we have lists that don't want to be changed? It's usually when you want to pair things together that are specifically going to be like that. So it can be like a name and your ID number. So you're not going to change your name anytime soon, or your ID number. So we can put that in a list, so we can have a list of tuples and stuff like that. It's basically just meant for specific implementations and stuff that is up to the developer. I personally don't use tuples a lot, but I know a lot of people that do. So how do we access the dictionary? So unlike lists or tuples, we have to use the same bracket notation, but instead of using the index number, an integer, we actually use the keys. So if the keys were numbers, we would put a number there. If the keys were Booleans, we would put a Boolean value there. But in our case, it's a string. So we access Friday by doing days bracket Friday, and then we get DOA, which is the corresponding value to that key. You cannot do days DOA and then get Friday back, because we can only search by keys, not values. The reason why we can't use an index is because dictionaries aren't ordered like lists. The way they're stored, it's actually just all random. So there's no really set order that you can access things. My favorite type of boba? Boba milk tea. Classic. The classic boba milk tea, bro. Actually, there's this really good thing on Gomta that I got that I totally forgot what it was, but I'll probably get it tonight. So altering a dictionary. If we want to alternate to add a entry, you do days, the key, and then equals the value. So in this case, we're adding the key Saturday with the corresponding value of this. I can't speak Irish, but that's what it is. And then if you want to delete entry, you would do del, which is short for delete, days, and then the key that you want to delete, which is Mondays, and this would delete the key and its corresponding value. Are keys only strings? No, keys can be anything. They can be anything. And in this case, we're just using strings because it's just easier for us to conceptually understand and teach, but they can be anything. So your turn. Create a dictionary with 3 entries with the key value pairs being the song name and the artist who wrote the song. How much time do we have left? All right, I'm going to give you guys like 20 seconds because I've been talking for too long. But just follow the format that's given above under the word dictionaries with the underline. It's a short little thing. If you just follow that and put it together. Why did I pick Gaelic? I just thought it was interesting. It was part of a programming contest that I did at UTD a couple of years ago. It's called UTD Battle of the Brains. Anyone's been part of that? Can you please pronounce the Irish word? Sadly, I can't. I'm Chinese, not Irish. So. Okay, so that's enough time. So it just be like this. So these are my 3 favorite songs that I'm listening to right now. Always by Keshi. What I say by Kanye West and on the album. And Better Off Without You by Julie Wu. And you're obviously going to have your own songs, but this is the format that it would be in. It would be the curly brackets and the colons, as you can see. Always, we would search always to get Keshi. We would say to get Kanye West. We can't search Keshi and get always. It's always the key is on the left and the value is on the right. So onto another data structure, sets. Sets are lists that can't contain duplicate items. This is really short, this is the only slide. They have similar functionality lists and they can't be indexed. So sets basically just have that only item. So if you try to add another one into a set, it only contains the one that's already in there. So you're basically just doing a mute thing. And it's also unchangeable. So if you try to change it, you get another type error. Set object doesn't support item assignment. So now we're on to mutability. We have mutable objects, which can be changed after creation, and immutable objects, which cannot be changed after creation. So some examples of mutable objects are lists, right? Dictionaries. We can change them after we initialize them. Some immutable objects are like the sets, the tuples that we talked about. Some things that also can't that are immutable are strings, ints, all these primitive types. You can't change them after you initialize them. You can reassign them, but you can't change the core value. Believe what I say slaps. That's true. So I just explained this, but you guys are supposed to answer, but whatever. Okay, for loops. This allows us to iterate over a set amount of values within a data structure. So it falls in this format. For each item in the item list, we do something for the item. Don't forget the indentation. You can see that there's indentation right there. So instead of using brackets, the indentation marks that is part of that for loop. So why loops? If you scroll down, you can see like a 50 line long block of code. And let's say we wanted to print out all the elements within inside this list, right? If we wanted to do a for a loop with the way how we do how, we'd have to write 12 lines, right? Because there's 12 fruits. And this is kind of pain. What if you had like 10,000 fruits or 20,000 fruits, and you have to print all the fruits? I don't even know there exists that many fruits, but if there were, you would have to copy and paste this over and over. So we can simplify it all to this 2 lines of code, right? So let's go through this. For each fruit in the list fruits, we print the fruits and the index, right? So this is kind of hard to understand at first, but once you put more work into it and try working with this list more, you'll understand more. Basically, we're traversing through the fruits list and accessing every fruit, and then we can manipulate this fruit in this indented block here. And we basically just go through the whole list, and the way we're manipulating it is just by printing it, but there's different things, like you can add the letter A after everything, so it'd be apple A, tomato A, persimmon A, and so on and so forth, and stuff like that. What is the difference between sets and tuples? Tuples can contain duplicates of an item. Sets cannot. Sets cannot contain duplicates of anything that's in it. So if it's already put in there, you can't put another one in there. Tuples, you can have like 2 number 1s in there and stuff like that. But the way they're the same is that they're both immutable, which means you can't change them. And sets can't be indexed, but tuples can. How does it know what fruit singular means if we haven't defined it? So it's actually defined in here. This is a definition. This counts as a definition. We're defining what we're getting from fruits as fruit. So basically what it's going through is it's going through each list in apple and it puts it in fruit, right? So it just assigns it like that. I'm kind of short, so I have to jump. Does Python not use I++? Python does not use Java or C++ syntax for loops. It's not int I equals 0, I is less than so-and-so, I++. That's not how it works. In fact, instead we use a range, like the range function we talked about. So we talked about for num in range 10, this is how we do our I++ version of it. So this corresponds for I equals 0, I is less than 10, I++. This is what it simplifies to. So basically we're going from every number from 0 to 9, because remember, 10 is not included. We're squaring them because the squared equals num times 2. That means it's num squared. And then we're printing it out by passing it to a string and printing out. So as you can see, 0 squared is 0, 1 squared is 1, 2 squared is 4, and so on and so forth, up to 9 and not to 10. And remember that we start at 0. Do we not have to define fruit in the for loop definition? No, you don't have to define fruit in the for loop definition. Whenever you do for blank in a list, that for blank, that will already be defined, so you can use it in your for loop, and it will only be used in that for loop, which is denoted by the block of indentation. If you go backwards on that block of indentation, it will no longer exist, and we can't use that variable anymore. If we're cubing a number, do we need to use times, times, times? So no, I mean, like you said, we can't just have like to the power of 1,000, just 1,000 asterisk, right? So there's a function called pow, and you can look it up, and it lets you do things to the power. Times times is just implemented because a lot of people like squaring things. I mean, not squaring things. I mean, wait, I thought about it wrong. Times times, the second thing on the side, you put it to the power. So it'd be 4 times times the power. So if you want to square it, it'd be 4 times 2. If you want to cube it, then it'd be 4 times 3. The time sentence means power, not to the power of 2. That's my bad. So a while loop. This is less common, not mostly used, but this is another useful loop, kind of similar to a for loop. It's a while loop, but the difference is that a while loop doesn't run for a pre-defined number of iterations, right? Because for a for loop, you define the blank in blank, it only runs until it reaches the end of the in, whatever it's in, right? Getting the stuff from. While loop stops as soon as the given conditional becomes true. So we can see that while is defined as while, space, and then a conditional. So in this case, the conditional is true. If you run this in your notebook and you click play, it's going to spit out like a trillion numbers. Click, don't panic, just click the stop button and it'll stop. Basically what this is called an infinite loop because it's always going to remain true and we never make it false. So it just keeps printing out n plus 1, n plus 1, n plus 1 to infinity until your computer dies, Earth explodes, universe collapses. Or until you stop it. So how do we make it stop? We have to define a conditional in which we can make it stop. So in this case, we define it as when n reaches 5. So if we put n equals 0, and then we define n plus 1, that means it will eventually reach 5, right? If we put n is more than 5, then it wouldn't run at all because 0 is not more than 5. So we basically just run until the conditional is false. And then, so now we're on to functions, which is completely different from loops. Functions allow us to package functionality in a nice and readable way, allows us to reuse code without having to write it again. If you plan on using really similar code more than once, it's probably better to put it in a function. So what does it look like? It looks like this. You have the definition, which is short to def. You have to have that to define a function. You have the function name, which can be whatever you want. And then you have the number of arguments. These are the things that you're going to pass in that are defined to use within the function. And then there's the statements that you're going to use the arguments in, and then you can return a value to whatever called it. Don't forget that there's an indentation right here. Don't forget indentation. Python is all about indentation instead of brackets, so it's kind of harder to think about, but always remember about your indentation. So here we have an example. We have the definition, and then we have the name of the thing, which is print num, and then we want to pass it a num in the arguments. So if we can see that it prints out my print number is num. And you can see that by passing it in through the arguments and defining it in the parentheses, it actually defines us that variable because anything where you pass in is going to be used as num and we print out. So if you see print num 9, my print number is 9, print num 7, my print number is 7, and so on and so forth. It's reused. So trying to make a function that adds 2 numbers and return it. There's a little block that has some empty things, but we have no time. So this is what you would have done. You would have put x comma y, you would return x plus y, and then you would put a b. So what this would do is we give it a, give it b, it turns into x and y, and then you return x plus y, which is 6. And then here are all the pre-built functions that Python has graciously made for you. A lot of these you won't use ever in your life, but there's some things like absolute value, there's some things like length, there's some things like power, and string, sum, tuple, and there's also round. So I would recommend looking at this. It's in the Python documentation. Just go to Python documentation, built-in functions, and you'll see this. And then there's also classes, which is important programming. It's really useful, but it's really advanced, and we have no time for this. But if you want to look it up on your own time, with Python classes, have a whole lot of fun and enjoy reading it all by yourself. But now you know Python, and we're over. That's it. You guys basically know the basis of Python. You can code using it, and you can do projects if you want to. And that's basically it. So here are some future steps. If you keep this link after this workshop, and when I go home, I'm going to put a lot of resources to continue your learning and more exercises I could do. If you go on there right now, there's a little link that says click here for exercises. It'll take you to a website, click the things, you can do exercises to practice what you learned. But that's going to come after the fact. And then we're also having another workshop that's also presented by yours truly about deep learning on this Friday at 7 p.m. the same time, in a room that is TBD. But that's it. Thank you all for coming, and I hope you guys learned something today, and be on the lookout for more resources on that GitHub.